Now that we have covered standalone and distributed deployment modes, let's look at one of the most important features of Kafka Connect, the REST API. The REST API is the primary way we interact with Kafka Connect in production environments. Rather than manually editing configuration files or restarting workers, we can manage connectors through simple HTTP requests. Using the REST API, we can create connectors, update configurations, monitor status, pause and resume workloads, and troubleshoot issues while the cluster continues running. In this diagram, we can see how the REST API works in a distributed Kafka Connect cluster. Notice that every worker exposes the same REST API endpoint. The user, automation tool, monitoring system, or CI/CD pipeline can send requests to any worker in the cluster. Behind the scenes, all workers share state through Kafka internal topics, connector configurations, task assignments, and status information are stored in Kafka rather than on individual machines. Because of this shared state, it doesn't matter which worker receives the request, the entire cluster sees the same configuration and operates as a single logical system. One important characteristic of Kafka Connect is that the REST API is available on every worker. By default, workers listen on port 8083. Although this can be customized, since configuration and status information are stored inside Kafka internal topics, any worker can answer API requests. This provides high availability because management operations continue working even if a particular worker becomes unavailable. In practice, this means administrators and automation tools don't need to target a specific worker. They simply communicate with the cluster through any available REST endpoint. One of the simplest API operations is listing on deployed connectors. This request returns an array containing the names of every connector currently registered in the cluster. When troubleshooting or auditing a system, this endpoint is often the first place administrators start because it provides a quick overview of what is currently running. After identifying a connector, the next step is usually checking its status. This endpoint provides information about the connector itself, as well as on associated tasks. You typically see whether the connector is running, pause, fail, or restarting. It also reports task level details and any error messages that may help diagnose problems. For operational teams, this is one of the most frequently used endpoints because it gives immediate visibility into connector health. Creating a connector is typically done using an HTTP post request. In this example, we're deploying a JDBC source connector that reads data from a MySQL database. The request includes the connector name along with its configuration settings, such as the connector class, database connection details, maximum number of tasks, and topic naming configuration. Once the request is accepted, Kafka Connect stores the configuration in its internal topics, creates the required task, and begins moving data automatically. Over time, requirements often change. We may need to increase parallelism, modify connection settings, or adjust connector behavior. Instead of deleting and recreating the connector, we can update its configuration using a request. Kafka Connect applies the new configuration and coordinates any required task restart automatically. This ability to reconfigure connectors dynamically is one of the major operational advantages of Kafka Connect. When a connector is no longer needed, it can be removed through the REST API. Deleting a connector stops on associated tasks and removes configuration from the cluster. Because Kafka Connect manages connector lifecycle centrally, administrators can cleanly remove workloads without manually tracking down processes or configuration files across multiple servers. Let's walk through what happens internally when a connector is created. First, a client sends a post request to one of the workers. That worker writes connector configuration into Kafka internal configuration. Because all workers uniquely monitor these topics, every worker becomes aware of the new connector configuration. The cluster then performs task assignments and distributes work across available workers. In this example, different tasks are started on worker 1, 2, and worker 3. Notice that the user only interacts with a single API endpoint, while the cluster handles all coordination and distribution automatically. Sometimes we need to temporarily stop data movement without removing the connector itself. The pause operation tells Kafka Connect to stop processing records while keeping configuration. Later, the connector can be resumed and continue operating using the same configuration. This is particularly useful during maintenance windows, downstream outage, or troubleshooting activities where we want to stop traffic temporarily without redeploying. Occasionally, a connector or task may fail because of a temporary issue such as network interruption or database out. Instead of recreating it, we can simply restart it through the REST API. Kafka Connect allows us to restart either entire connector or individual task. This targeted recovery capability helps minimize disruption while quickly restarting normal operation. Before deploying a connector, it's often useful to validate the configuration. The validation endpoint checks whether the required settings are present and whether values are correctly formatted. This helps mistakes before deployment and reduces operational issues caused by configuration errors. Many automation pipelines use validation as part of their deployment process to ensure connector configurations meet requirements before reaching production. In real-world environments, the REST API is rarely used only by humans. CI/CD pipeline can automatically deploy new connectors using API requests. Monitoring systems can regularly check connector health status. Operations teams can investigate issues, restart failed connector, and gather diagnostic information. Dashboards can consume status information and present it visually for administrators. Together, these capabilities allow Kafka to integrate naturally into modern DevOps platform workflows. Let's summarize the key points from this lesson. Every Kafka Connect worker exposes a REST API, typically on P083. The API is available on all workers because connector state is shared through Kafka internal topic. Using the REST API, we can create, update, monitor, pause, resume, restart, validate, and delete connectors without restarting workers. This makes Kafka Connect highly manageable, highly available, and easy to integrate with automation platforms, monitoring systems, and CI/CD pipelines. In the next lesson, we'll examine how Kafka Connect achieves parallelism, fault tolerance, how work is distributed across workers,